All right, this is on composition of functions. This is an extremely important topic, and it's sometimes gives students some trouble, but it really is just a fancy way to substitute. Okay, so I'm going to try to do it a little creatively so you can see what's happening. So when we have something like this in function notation, see, this is our function in terms of x, 3x minus 4. So if we write something like this, f of negative 3, what it's saying is, instead of x, I want negative 3 to be plugged into the function instead of x. So what's happening is I'm going to actually rewrite this. Here's 3. I'm going to put the x minus 4. Okay, and I'm going to take this right here, this number, this negative 3. Okay. And I'm going to paste it. Here's my negative 3. Oops. Gotta switch to my pointer here. I'm going to take that negative 3 and I'm going to drag it and substitute it right in there. See what I'm saying? You take the negative 3, I'm going to plug it right in there for x. Okay? I'm going to tell you a hint that you really need to do. It's extremely important. I'm replacing that x and I want to put that in parentheses, okay? And there's a reason we're going to do that, to make things a little bit easier. Otherwise, it might have looked like I was doing 3 minus 3 instead of 3 times a negative 3. Okay, so this is going to end up being negative 9 minus 4, which is negative 13. Okay, now this right here is called composition of a function. So it's basically taking a function and sticking it into another function. Like I said, it's just an elaborate way to substitute. Right, so what I'm going to do here is I'm going to rewrite my f function. Here it is. 3 times x, I'm going to leave some space for a reason, minus 4. Okay. Now what I'm going to do is I'm going to take this is my g function. This is g of x, see? I'm going to take my g function and I'm going to plug it in for my x, okay? So, get a little fancy with that. So I'm going to take this, I'm going to cut that out there, take that function. Okay, here it is. I got to go back to my pointer here. See, now I got a hold of it. Here's my function. I just grabbed it, and I'm going to replace that x. See, I'm going to substitute it right in there. Okay. Now remember, I talked about those parentheses before. It's really important to put the parentheses around that. So whenever you take the function and you substitute it into the other function, put parentheses around that to make sure you do all of the operations properly. Okay, now when we just multiply this out, we use the distributive property, 3x squared minus 3 minus 4, and we can simplify just a little bit more and rewrite that as 3x squared minus 7. Okay, same idea, I'm going to do it again, but in this time I'm going to take the f function and plug it into the g function. Okay, so it's going to look something like this. I'm going to rewrite this function and just kind of leave some space. And you'll see, you'll see why in a minute. Okay, so x squared minus 1. Now I'm going to take this function here. This is my f function. Okay, and let me pick that up. Pick that function up. Here it was. I just copied it. And I'm going to plug it in right there, in for my x. I'm going to replace it. And like I said before, we're going to make sure that we use some parentheses to make things a little bit clearer. So we do things in the proper order. Now see, we have to square this and then subtract off 1. So basically we're doing, we're foiling this out. We can write it over here to the side if it helps you. So we're going to use our distributive property and do first, which is 9x squared. And our inners, or outers, doesn't matter, negative 12x. The inners are also a negative 12x, and our last would be a positive 16, and then we still have this minus 1 over here, so I'm going to tack that on. So when we simplify all this, we get 9x squared minus 24x plus 15. And this is the composition of the g of f of x, taking the f function and plugging it into the g. Okay, now I'm going to have you give this a try. On the next slide, you have two functions, the f function and the g function, and you're going to do g of f of x. You're going to take the f function and plug it into the g function. Okay, go ahead and give that a try. Okay, how'd you do? Hopefully you did okay. I'm going to kind of do it the long way like I was showing you before using my cutting and pasting. I'm going to take this g function and rewrite it, just leaving some space. You don't have to do this, but I'm just trying to make it very visually clear what you're doing here with this substitution. Just leaving myself some space. So I'm going to take my f function and I'm going to copy that. I'm going to pick that up. Oh, it landed right on the x where it was supposed to go. I'm going to stick that right there. Okay, I'm going to copy it again. There's another one, and I have to also stick it here because I have two x's. I've got to replace both of those x's with the 2x, with that function. Okay, hopefully you notice that. And I'm going to put this in parentheses and this in parentheses to drive home that I'm squaring the 2 and the x. I'm squaring the entire function. This entire function is getting plugged in. So we would end up getting 4x squared plus 2x. And that would be the composition of the g of f of x function. One more thing in your book, sometimes you will see composition and it will look like this. It'll be an f and a tiny circle and a g, okay? That does not mean multiplication. That means composition, okay? A dot is multiplication and this tiny little circle here is called composition. So if you see f with this tiny circle and g, it does not mean multiply the functions. It means you are doing a composite. It means this, f of g of x. That's what that means, okay? This does not mean multiplication. All done.